Example 4. Find the derivative from first principles of y is equal to the root of t. The solution. If y of t is equal to f of t, which is equal to root t, this means that y of t plus h is equal to the square root of t plus h. Then, from the formula, dy dt, taking the limit as h approaches 0 of f of t plus h minus f of t over h would be given in this form. We substitute for the f of t plus h and the f of t so that we have that. However, we have a situation here. How do we deal with the square roots? Now, we would need to now introduce the conjugate of the numerator, which is given as that. Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the differentiation from first principles. This is differentiation part 2. Make sure to check out our part 1 so that you don't miss out on any of the differentiation series. Recall, from differentiation part 1, suppose that we have y is equal to f of x. And if we display what we have here on a graph, we would have something of this nature. And having points A and B, where f of x is the point A and y is equal to f of x plus h is point B. Then the gradient of the curve y is equal to f of x at the point B is approximated by the gradient of the chord AB obtained by dy dx is equal to the limit as h approaches 0 of f of x plus h minus f of x over x plus h minus x. Simplifying this further, we are going to have the numerator being equal to h, as the x and the minus x cancel out, where h is a small change and lim h arrow 0. This is the same as saying the limit as h approaches 0. Now, that dy dx is what we would refer as differentiation from first principles. Now, let's look at an example. Find the derivative from first principles of y is equal to 2x. The solution. If y of x is equal to f of x is equal to 2x, this means that y of x plus h is equal to f of x plus h, which is equal to 2 times x plus h. Now, simplifying this further, we are going to have 2x plus 2h. Then, from the formula, dy dx, limit as h approaches 0 of f of x plus 1 minus f of x over h, we can go on to substitute for the f of x plus h and the f of x so that we have it in that form. We open the bracket in the numerator. We are going to have dy dx is equal to the limit as h approaches 0 of 2h over h. Now, we see that we have a common factor, h. As this cancels out, we end up having the limit as h approaches 0 of 2 is equals to 2. This will be our final answer. And take note, the limit of any constant c as h approaches 0 is equal to that constant c. So that is what we have from this example. Let's look at example 2. Find the derivative from first principles of y is equal to 4x squared. The solution. If y of x is equal to f of x is equal to 4x squared, this means that y of x plus h is equal to 4 times x plus h all squared. Now, we can simplify this one further by expanding the parenthesis or the bracket so that we have 4 times x squared plus 2xh plus h squared. And of course, expanding the bracket to introduce the 4 inside the bracket, the pair of brackets or the parenthesis, we are going to have 4x squared plus 8xh plus 4h squared. Then, from the formula dy dx, we are going to substitute for the f of x plus h minus f of x, so that we have our dy dx being limit as h approaches 0 of the fx plus h minus f of x over h. Then we see that the 4x squared with the negative 4x squared will cancel out, so that we are left with limit as h approaches 0 of 8xh plus 4h squared over h, and we have a common factor here between the numerator and the denominator of h. So the h will cancel out, so that we are left with the limit as h approaches 0 of 8x plus 4h. Then we can distribute the limit in this format, where we have the limit as h approaches 0 of 8x plus the limit as h approaches 0 of 4h. With that, we are going to have dy dx being equal to 8x plus 4 times 0. Remember, all the h terms go to 0, implying that our answer comes out as 8x. Great. This is the logic that we use in differentiating from first principles. Let's look at example 3. So in example 3, we have the function given to be y is equals to t cubed minus t squared, the solution. Now, if y of t is equals to t cubed minus t squared, this means that the yt plus h is going to be given by t plus h all cubed minus 2 times t plus h all squared. We can expand the brackets or the parentheses so that we have those terms. Then from the formula dy dt and substituting for the f of t plus h with the f of t as well, we are going to have dy dt given by this huge function that we have, especially in the numerator, all over h. Now, we can see that some terms will cancel out. T cubed and minus 2t squared will cancel out, so that we are left with the simplified version of dy dt being that. And additionally, we see that also we still have a common factor, which is h in the numerator and the denominator. As these cancel out, dy dt is equals to limit as h approaches 0 of 3t squared plus 3th plus h squared minus 4t minus 2h. And take note, all h terms go to 0. With that in mind, it means that our dy dt will be equal to 3t squared minus 4t, and that will be our final answer. Let's take a look at example 4. Find the derivative from first principles of y is equals to the square root of t. The solution, and as usual, if y of t is equal to f of t, which is equal to the square root of t, this means that the y of t plus h is equals to the square root of t plus h. Then, from the formula dy dt as limit of h approaches 0 and substituting for the f of t plus h minus f of t all over h, we are going to have our dy dt as that. However, we have a situation over here. We would need to get rid of the square roots, and to do so, we would need to multiply the numerator by its conjugate divided by the same conjugate. So what we have done here is simple manipulation, because we see that conjugate divided by the conjugate is as good as a 1. So we did not change the problem. But what we have done is we have dealt with the square root sign. Why? Because square root of t plus h will multiply with the square root of t plus h, this one, to give us a t plus h. And the last root t's, one being negative and the other one being positive, will multiply to give a negative root t. Now in the denominator, we'll still have the conjugate multiplying with the h, as we have it in this form. And of course, simplifying further, we are going to have our dy dt being given as the limit as h approaches 0 of h over h times the conjugate. And take note, we have a common factor between the numerator and the denominator of h. So the h terms will cancel out, so that we end up having limit as h approaches 0 of 1 over that conjugate. Then we know what follows next. All h terms go to 0. And when that happens, what we are going to have is our answer is dy dt is equals to 1 over 2 times root t, or simply put, equal to 1 over 2 times t to the power minus a half. And that solves question 4. So that's how we solve this problem. And take note of the conjugate. We introduce the conjugate. Let's look at example 5. Find the derivative from first principles of y is equals to 2 over 5t plus 1. This time around, we're dealing with the fraction. The solution: if y of t is given to be f of t, which is equal to 2 over 5t plus 1, this means that y of t plus h is going to be 2 over 5 times t plus h plus 1. And of course, expanding the brackets or the parentheses, we are going to have the numerator as 5t plus 5h plus 1. Then, from the formula dy dx, we are going to substitute for the f of t plus h and subtract f of t. In so doing, we are going to have our dy dt as the limit as h approaches 0 of 2 over 5t plus h plus 1 minus 2 over 5t plus 1 all over h. And as you would know, we can actually combine the two fractions in the numerator so that we have that huge chunk and still have our original numerator as h. And of course, we know that dealing with fractions, we can actually express this in terms of that. So we now have one numerator and one denominator. And of course, we simplify further by expanding the brackets. So expanding the first brackets, we are going to get 10t plus 2 minus, all in brackets or parentheses, 10t plus 10h plus 2. Now, we see that when we expand the bracket that is in the numerator, we are going to have some terms that are going to cancel out, so that what we have is our numerator is a minus 10h, and we still keep our denominator. Now, we also see that between the numerator and the denominator, we have a common term, which is an h. So the h will cancel out. When the h cancel out, we are going to have our dy dt as limit as h approaches 0 of minus 10 all over 5t plus 5h plus 1 multiplying 5t plus 1. And of course, the next step is obvious. We set all h terms to go to 0. And when that happens, what we are going to have is our dy dt being equal to minus 10 over 5t plus 1 squared. And that's how we solve from first principles. Now, I'll leave you with the following task. Find the derivative from first principles of y is equals to the square root of x minus 3. Thank you so much for watching Numbers Simplified. Remember, in this channel, your comments, your feedback is always welcome. Make sure to subscribe so that you don't miss out on any of our future uploads, especially in the differentiation series. God loves you.